So I did an example calculation of standard deviation, the population standard deviation in the last video. So now I want to give you the formula that we use for standard deviation. So in the last video, I calculated all of my deviations. So those were the values here. I squared those values, took a sum, divided by how many I had, and then took a square root. So we can summarize all these steps by saying that sigma, so that's the sample standard deviation, is the square root, that was the last step that we did, of a sum. And what was it that we added up? Those were all of our deviations, where I took each value, subtracted the mean, and then squared it. So, and before I took the square root, I divided by how many values I had. And so, since this is a population, I'm going to use a capital N. Oh, and I made a mistake here too. Since this was a population, I actually used mu. Let me just write that in red. So this should be a mu, and this should be a capital N. So, just to kind of bring this all together, this step here where I'm taking x minus mu, that was this step here where I took all the differences. The sigma, the sum, then the square here, that's what I did here where I took each of these values and squared it. So that was this step. So that's what this is telling us. Summation says add those all up. That's how I got the 662. Divide by how many you have. That's what I was doing here. And then finally take the square root, which is what I did here to get my answer. Again, if we wanted to just find variance, I would not take the square root. I would just take the sum of my differences squared and divide by how many I have. So this is population standard deviation, and this is the population variance. So standard deviation tells us the typical deviation from the mean. So in this example, I could say the typical deviation from the mean was 7.4. And if I had some units, I would put that there. Now, for the sample standard deviation, our formula changes just slightly. So we're still going to take the square root at the end. It involves a sum. I take all of my deviations. Now in this case, I'm going to use x bar because I'm using the sample mean to calculate the sample standard deviation. I still square all those differences. Those are my deviations squared, sum. Now, instead of dividing by n, for the sample standard deviation, we divide by n minus 1. So the reason that we do that is kind of beyond the scope of this text. So I'm just going to ask you to accept that for now, or you can do some research on your own if that's not good enough for you. We also can say that we have sample variance, and just like with the population, we will not take the square root. We'll just have our sum of the deviations squared divided by n minus 1. So this is sample standard deviation, and this is the population standard deviation. And one more thing, this n minus 1, we call that degrees of freedom, and that will come up throughout a statistics course. So I'll go ahead and introduce that term now. In this calculation, the degrees of freedom is n minus 1. That's our sample size minus 1. In the next video, I'll discuss the empirical rule and some of the applications of standard deviation. I hope you'll join me.